Hi everyone. Hope you all are keeping safe and still giving your best in the fight against COVID-19. In this video, I'm going to discuss how you can help with dataset curation for COVID-19 Universal Knowledge Graph. The first step in dataset curation is to choose a research paper. And the data source which we are considering is WHO COVID-19 database. This database contains research papers from a wide variety of sources. It has around 55,000 research papers. 56,974 research papers to be exact. And as you can see, these research papers are from multiple sources. You can choose any research paper of your like. For the purpose of this demo, I will choose a research paper related to vaccines. The paper which I will be considering will be this: host pathogen interaction in COVID-19, pathogenesis, potential therapeutics, and vaccination strategies. The next step is you have to open the Universal COVID-19 Knowledge Graph Dataset Curation form and enter some fields: the COVID WHO ID, your name, research paper title, and research paper authors. So as you can see, this is the form which you are required to fill. In this form, you will fill these fields as just mentioned, and also the entities which you will be extracting and curating. So first comes the COVID WHO ID. The COVID WHO ID can be read from here, COVID WHO, and this is the ID. Let's take this and put it there. Then you have the name field, which is your name. So say it is Shyam Kumar. These are not actually autocomplete fields. So what you actually see is the name stored in my session. Then you have to enter the title of the paper. The paper title is this. Following which you will enter the authors. So far, so good. Now comes the main data curation exercise. You have to add the data for the research paper to the data set, and I have provided sample curation for one research paper. This is the research paper for which sample curation has been provided, and the sample curation is available here. In fact, if you look at the form for dataset curation, all these links are available here also. The WHO COVID-19 database, the sample research paper, dataset curation for the same. And besides that, I have COVID-19 knowledge graph resources. So this is my channel where I present different aspects of knowledge graphs related to COVID-19, how they are useful, what are the challenges being faced, how manual curation helps, and so on and so forth. You can visit my channel and see all videos there. Coming to dataset curation, first of all, I'll be explaining to you how I'm doing this curation for the already done research paper. So I'll be illustrating how this research paper was curated. And after that, I'll also show how you can do dataset curation for the research paper which I've just chosen. So dataset curation involves extraction of entities and relationships between them from this research paper, from a given research paper. And the idea is to extract as many entities and as many relationships between those entities as possible from a given research paper, and to store them as part of a consolidated framework, which is our knowledge graph. Now, let us do that exercise. Let me demonstrate how I've done this for this research paper. This research paper is titled as Drug Targets for COVID-19 Therapeutics, Ongoing Global Efforts. I've already curated this research paper. So in case you were to choose a research paper which is already done, say, well, let me refresh it. You were to choose this research paper. The COVID WHO ID for this research paper is this, and you enter it. And suppose you were to add any other name except mine, say Ram Kumar. this would automatically ask you to select a different research paper, as this has already been taken up by somebody else. So you also need to be sure of that. Let me fill the details once again. Because we had not yet submitted. This was our ID. Name could be anything, say Prashant Sharma. I mean, your name, of course. Paper title was this. Oh, available here also from my session. And the authors were these. The authors seem not to be available. Let me check. No, you can paste them. But when you already submitted, once you submit it, you will be able to just get these things back from by just entering this and this. So coming back to data curation, when you read the first line of this first paragraph, it says follows. The current global pandemic COVID-19 caused by the SARS-CoV-2 virus has already inflicted insurmountable damage both to the human lives and global economy. Now, when you read this line, you immediately find that there are two very important relationships here. That this COVID-19 has been identified as a pandemic, and the causative virus for COVID-19 is SARS-CoV-2. Now, it is important to capture these relationships, and I've done them in my sample data set. So COVID-19 is identified as the source node. Pandemic is identified as the target node, and the relationship between these two is that of status. So status of COVID-19 is that it is a pandemic. And the reason for actually adding this relationship, the reason for giving importance to it, is because there would of course be other pandemics. And it is important to ensure that we capture information related to all pandemics so as to be able to identify similarities and differences between different pandemics. So this will make our knowledge graph complete. The next relationship which I've considered is the relationship between COVID-19 and its causative virus. So I mentioned that COVID-19, the causative virus for COVID-19 is SARS-CoV-2 and SARS-CoV-2. And then when you read further, you see this is kind of generic stuff. So this is not something for which you might like to add notes in your knowledge graph. So this is just, there is an immediate need for identification of active drugs to contain a disastrous virus outbreak, of course. And global efforts are already underway at above footing to identify the best drug combination to address the disease. So this is generic and need not be added to the knowledge graph. When you move to the next paragraph, you have figures quoted as regards the number of infected cases and the deaths all over the world. Now these are stats which change on a day-to-day basis. So it's not worth including them inside a knowledge graph. However, then you have a mention that this COVID-19 has been designated so by the World Health Organization. And I think this is an important relationship to capture. Again, because World Health Organization would be dealing with different diseases. And once we have this node in our knowledge graph, we will be able to connect to all those diseases which are being referred there. And it's quite possible that we may get some important relations, some important interconnections between COVID-19 and those other diseases, and those interconnections are established through the World Health Organization node. So I add World Health Organization node there. I add COVID-19 and WHO, and the relationship is that WHO is the organization which is designating the disease. Which disease? COVID-19. Now, as you can see, the source is something which you extract from the research paper, and the target is also extracted from the research paper. By and large, this is a way. There are, of course, cases where you have to rephrase what is there in the research paper so as to present it better. But then essentially you extract source and target from the research paper, and in many cases you may have to write relation by yourself. There would be cases where you can simply take it from the research paper, but by and large this exercise has to be done from our end. So this needs to be done carefully. Efforts should be made to, as I'll demonstrate later, to select the fields which are already available. So for example, if you're talking about infection, you can simply select infect. If you're talking about, say, a full form, if you want to express the full form for SARS-CoV-2, you can just use this. So this will ensure that we have a minimum set of relationships. We actually have the least, the most kind of specific set, a non-repetitive set for our relationships in this. And this applies to other nodes as well. This applies to source and as well as target nodes. Going further, they talk about that there is an absolute definitive drug or vaccine available that can contain the spread of this deadly virus, which is fine. And then they talk about the management strategy for the disease, which is primarily aimed at treating the symptoms. Now, this is an important attribute regarding COVID-19. So I capture this here, that before that, I actually capture the full form of SARS-CoV-2, which is mentioned here. And after that, I mentioned the management strategy for COVID-19, which is aimed at treating symptoms in absence of absolute definitive drugs or vaccine. So going further, I see that in this paragraph, there is not much useful information. However, when we move to the next paragraph, we see lots of useful stuff. They talk about other pandemics created by coronaviruses. They talk about SARS and MERS and how these are related to COVID-19. And further, they talk about the causative virus of COVID-19. They talk about coronaviruses, the features of coronaviruses, why are they named so, what are the different categories of coronaviruses. All this is stuff which I have described in great detail in terms of which I've extracted in great detail in my dataset curation. So if you look at this entire dataset curation, this is around some 472 source relation target triplets, and all of them have been extracted from this research paper. Now let me do this live for the research paper that we chose. The research paper that we chose was this. Let me open this research paper. The full text is available here. So what you see here is the abstract. I would encourage you to come to the abstract only after you are done with the rest of the research paper, because generally abstract is found to be more or less generic. It's found to be a kind of summary of the research paper or what the author plans to discuss in the research paper. And of course, other sections like introduction and details are much more specific. So when we go down, well, they have a graphical abstract as well. And this would contain some useful information. And as you can see, this is a kind of, these are interlinked relationships between different entities. But then as you would appreciate, it's difficult to extract them from this research paper through scripts. That's why we are doing manual curation. When you go to the research paper is available in PDF form here. Let me download that. Good. It's downloading. I think it's long, a long research paper. Extensive. So if you were to look at the language which is present in these research papers, you would realize that some of the sentences are pretty simple English sentences. However, when you go to the actual research paper, this was the abstract. But when you go to the other sections, like the introduction and main sections, as in molecular and genomic characteristics of SARS-CoV-2, molecular evolution, major receptors, you find that they contain references to all kinds of biological entities. And then the sentences also become more complex, and that becomes a challenge then for automated extraction of these nodes and edges. So this is the reason because of which manual curation is being requested. Let me start with the introduction. And when we read the introduction, you see the first sentence is coronavirus CoV is the largest known RNA virus that belongs to the family of Coronaviridae. So you see this sentence itself contains two or three important relationships. One is that coronavirus is abbreviated as CoV, or the full form of CoV is coronavirus. The other is that coronavirus belongs to the family of Coronaviridae. And the third thing is that it is the largest known RNA virus that belongs to this family. Let me show how you'll go and add this into the data curation form. So you will take this short form and you will actually enter CoV. So this is already there. Because a number of research papers have already been curated, you would find that there would be whatever you're going to fill, those would already be part of the pre-filled set, and you must choose from there. Because if you specify entities differently, it's going to become complex later. The very reason of having these fields as autocomplete is so as to ensure that we choose whatever is already available. If we are just talking about the same thing, we choose from the set what is already available. If we are talking about the same thing, of course, if you're adding something new, you will add it from your end. Because we were talking about CoV, we just chose it from here. And we want to talk about the full form of CoV, so you just add the full form relationship. And the full form of CoV is coronavirus. So you just choose coronavirus from here. Now you could have also done it the reverse way, coronavirus abbreviation and CoV. Because I just happened to take full form relationships rather than abbreviation relationships, so I did full form here also. But even if you mention abbreviation, that's no problem. Let me add another note to this, and another relation, source relation target triplet pair to this, triplet to this. And the information which we will be adding is that this coronavirus belongs to the family of Coronaviridae. So let's take this once again, or we can choose from here. You could as well write CoV. We have to talk about the family of coronavirus, and this is Coronaviridae. So again, this has been should taken up. This should have been taken up as part of a different research paper, and yes, it has been. So you already find it there. And similarly, we can go on adding different relationships, which I'll just do. But the point is, one point which I want to illustrate is, at a given point of time, you may not want to add all relationships altogether, because this is a pretty extensive form and you will need some time, some good amount of time to finish this. You may want to do this exercise over a couple of days, over 5 or 6 days, maybe just by spending 5 to 10 minutes at one point of time. So in that case, what you may do is you may just fill a few relationships of a few source relation target triplets, and then just submit the form. Once you submit the form, I mean, you can always come back and refill the form once again, as many times as you want. So the data which you submitted would of course be stored, and you wouldn't have to fill the authors and titles once again. So for example, this was my COVID WHO ID. So you would of course need to fill the COVID WHO ID, and you would need to fill your name. So in this case, the name which I had filled was Prashant Sharma. And when you do that, the details already come. In case, as I mentioned there, if a different person were going to fill against the same ID, he would get a message for that, alerting to choose a different research paper. Now let's go further. So we already took two relationships from here. Then another important relationship is that this coronavirus is in fact the largest known RNA virus in this family. So we curate that as well. And this is an attribute of coronavirus. So we take the relationship as attribute. And the attribute is that it is the largest known RNA virus that belongs to the family Coronaviridae. And we just check it. This is an important relationship which may be useful. And we just add it. Going further, this talks about that these viruses, coronaviridae class, are known to infect a range of animals, including humans, and cause respiratory, gastrointestinal, and neurological diseases. Well, this is again useful stuff. So you can mention that coronavirus infects animals, including humans. Even if you mention animals, it should include humans. But then, because we have other relationships where only human beings are considered, it's worth mentioning these two as separate categories. So coronavirus, and then you can use the relationship as in fact, and then you can mention animals. So animals is not there, so I mention animals separately. And the other relationship which I have to consider, well, let me close this, is that of human beings. So coronavirus impacts human beings. Infects human beings. So human beings, this is you already have, so this would have been taken up as part of a different research paper. Good then. We add more relationships. This is talking about that coronaviruses cause respiratory, gastrointestinal, and neurological diseases. Let me just add one of them. I mean, it's the same process for others. So the demo is same for others. You mention coronavirus, you again choose it, and then you mention it causes what? Say neurological diseases. I mention neurological diseases. Good. Similarly, you can add gastrointestinal and respiratory diseases in different routes. Then they talk about classification of coronavirus into 4 categories. So this is an important relationship, and then you can just write that coronavirus is classified into I think you already have this relationship. So there would be other classifications as well. So you have already have this classified into relationship available. You can choose from there. And they are talking about alpha coronavirus, beta coronavirus, gamma coronavirus, and delta coronavirus. So let me just take one of them. Say I take gamma coronavirus or maybe delta coronavirus. So I'll take delta coronavirus and I'll add it. I'll first see whether this is available there or not. So as you see, delta coronavirus is already available there. It's good. I add it. And then the other relationship which I have to consider is, or rather the notation which I have to consider is that this delta coronavirus is also represented as this. So this is a notation. This is a notational relationship for delta coronavirus, which I go and add to my form. Again, the notation relationship has been included before. It must have been included for something different. NO notation, good. And we choose a notation here. And we can do it for other viruses, other subgroups. Then they mentioned that alpha coronavirus and beta coronavirus use bats and rodents as animal reservoirs, while they use members of avian species as reservoirs. So let me just mention about alpha coronavirus. So if you already curated alpha coronavirus and its notation is alpha COV, this would, and if you were to submit it, if you had submitted it already before, this would be there. But and similarly for others, as in for beta coronavirus, gamma coronavirus, and delta coronavirus. But I'm skipping that part of it right now. I'm just illustrating how this is done. So they're talking about animal reservoir of these viruses. So you just have a relationship of animal reservoir, and you see whether that animal reservoir, whether it's already there. So it's not there, so you add this relationship, and the animal reservoir is bats. So I think bats would be there because they have been taken up in a different research paper. That's good. Let's go to further relationships. Here they talk about a total of 7 human infecting coronaviruses that cause respiratory distress of various kinds have been identified. So, and these include 2 alpha COVID viruses, uh, 2 beta coronaviruses, and then they talk about the highly pathogenic beta coronaviruses, I mean, which cause epidemics. So, fine. What you can see, you see these are human infecting coronaviruses. So, all these are examples of human infecting coronaviruses. So, this is an important relationship to capture. These are human infecting coronaviruses, and all they have is examples. Say this is one example. Similarly, you can add other examples too. Let's go further. I wanted to illustrate a relationship where you would actually have to add more than a few words, and you should be able to make use of this LinkedIn. You should be able to understand what is the basis behind these linked to relationships. So, for example, this talks about the genome SARS-CoV-2, as in it is a large positive sense single-stranded non-segmented RNA genome of 29,903 nucleotides in length. Okay, this is an important relationship, but again, this could be split into 4 different relationships, as in 4 different characteristics of SARS-CoV-2 genome. You see, for example, I'm talking about a process here. This research paper is talking about a process here that the genome of SARS-CoV-2, like other beta coronaviruses, is complex and tightly packed with 2 open reading frames, ORF1 and ORF1b, ORF1a and 1b, which code for non-structural proteins, other structural proteins, as well as viral regulators and transcription factors. And this is specifically codes for polypeptide 1a of approximately 500 kDa, which is subsequently cleaved into this. And then they talk about a ribosomal frame shift, which is proximal to stop-on codon of ORF1. So this is where the actual biological stuff comes in. And this actually makes it difficult for automated extraction of nodes and relationships. But to illustrate the point which I'm making is, for example, you have a relationship between these 2 sentences where you are mentioning that you have this results in a larger polypeptide of approximately. So what results? ORF1b is translated as part of a larger polypeptide, which is produced through a continuous translation of ORF1a and ORF1b because of a ribosomal frame shift that is proximal to the stop-on code of this. So this stuff is referring to continuous translation of ORF1a and ORF1b. So what you would mention is, you would mention translation of ORF1a and ORF1b as your source node. And then you will have a relation leads to, in which you can mention, or you could either write results in. I just wrote leads to because generally I use this phrase when I talk about such processes. Do you have a results in here? So you have results. So the results is a kind of noun. Better use leads to. You could use results in also, but leads to is already there. It's better that way. So it is the result is a larger polypeptide of approximately 800 kDa that is cleaved into this and this. So see, this is a complete relationship in itself, as in this is a complete entity in itself. This is a complete, I would say, complete status, a complete entity, as in you have a polypeptide which is described here. So you take up this information and put it here. Good. And because you see this relationship itself, as in the target node, the larger polypeptide of approximately 800 kDa is cleaved into 15 NSPs by viral proteases NSP3 and NSP5. This itself contains references to other entities. Then you would add a linked to relationship. When you add these linked to relationship, it will be easier internally to actually connect these targets, I mean targets of this kind, and this target in particular in this case, with the relevant entities, so that wherever those entities occur, the respective connection is established. So this talks about 15 NSPs. So you can mention 15 NSPs, or you could also mention, say, NSP3 in particular. I mean, you should mention all of them, of course. So one at a time. So if you mention NSP3, here, let me delete it first. So you find that NSP3 is already, well, NSP3 is not there. So, well, it's good, and it's good. So there is a reference, there are references to all NSPs here, but NSP3 is not there. So you would add NSP3 here, added. And then they talk about NSP5, which is already there, and so on and so forth. So this way, when you go through the respective segments, respective sections, you will find there will be plenty of these relationships where you actually extract the full phrase or the full clause or even the full sentence. Because what that sentence represents is a result. What it represents is a state, it represents a condition. I mean, there may be a phrase which represents a condition, and it is essential to capture in its entirety. And this, with the help of link to relationships, you can link them to the entities which are contained inside them. And this way we will be able to build a single unified knowledge graph for the entire research paper. And when this exercise is done parallelly for different research papers by different people, we will be able to make this COVID-19 knowledge graph very quickly. So the graph technology has been there for quite a long time. It's not something new. It's not something that has to be tried. It's only the data which is challenging to extract. So some data may be easier to extract through automation, and indeed that is the case. But for most of this data, for example, when you go into the intricacies, when you are talking about these processes and the entities involved therein, as you can appreciate yourself, it becomes difficult to extract the processes one by one in their sequence and then specify the entities mentioned therein, because there are many a time when you have to rephrase even the statements mentioned here just to ensure that they are entered into the graph into the right format. So this is the way in which you will be adding nodes and relationships for a given research paper. And as I mentioned, in this form, you already have this video available. You can always, when you are in this form, if you have any confusion, you can refer to it directly from here. And the the WHO COVID-19 database, the sample research paper, data curation for that, and COVID-19 knowledge graph resources are available. So in this, you can go and look at what knowledge graphs are, how knowledge graphs help in, how they can help in fighting COVID-19. I've also discussed how we can make how knowledge graphs from this curated data set. For example, in this video, I have illustrated knowledge graphs made using manually curated data set. I discussed the challenges in automation of extraction of nodes and relationships as far as COVID-19 research papers are concerned. So you have plenty of stuff. I've talked about the existing research papers, the existing COVID graphs, and what are the challenges with them. So it would be great if you could go through all of them, and this will give you the context to this. People, I think this exercise demands some time from you, say maybe an hour and a half. But if you were to contribute to this, say over a period of 5 to 6 days, you could just do it by spending 5 to 10 minutes per day. And if we are able to do this, if you share it with your friends, with your relatives, whom you think you can help, it will be very useful. You all need to know some basic English. I mean, I don't think you really need to know biology. So whatever I have curated here doesn't really require knowledge of biology. It requires knowledge of English. But then as human beings, when we read paragraphs, when we read sentences, when we read different paragraphs, we are more easily able to extract relationships even between different paragraphs. With machines, as of now, it is difficult. With NLP, it is difficult. I work in the area of NLP, and NLP is not so advanced as of now that it can extract relationships from multiple paragraphs uh, in a most accurate manner. So that is why I am having this as manually curated, these research papers as manually curated, because accuracy is of paramount importance here. So I hope that you will be contributing to this. You will be choosing a research paper of your choice, curating the data set for that, and submitting it in the portal. I sincerely believe that if we are able to do this exercise very quickly and then make the knowledge graph, we can help our scientists and researchers find unknown relationships between these different COVID-19 related entities, and who knows, the relationships entered by you, the unknown relationships which may be discovered when you enter the nodes. These relationships can help the scientists in finding new ways of designing drugs, vaccines, and other forms of treatment related to COVID-19. I would also like to mention here that some of these relationships, some of these research papers, in fact, many of them, contain novel suggestions on vaccines and drugs in context of COVID-19. And I have a specific node in my research paper data set, which is potential strategy against COVID-19. Well, let me add it as a separate node here. So do we have some reference here? Molecular evolution of SARS-CoV-2, major receptors for SARS-CoV-2, promoting viral protein building. We'll have to read it in greater detail. But say, suppose there is some suggestion as to some design of a novel vaccine, as regards to the design of a novel vaccine. So what you find, there is a node which I'm specifically referring to here, and the node is potential strategy against COVID-19. In this node, you can very easily specify whatever is being referred to. So if a person is just asking you to use a particular chemical or a particular drug which he thinks is useful and proves it's useful, then you'll just mention use drug ABC, whatever it is. And if they are talking about how certain vaccines can be developed, you will mention a process here. So this knowledge graph, apart from establishing relationships between all COVID-19 related entities, will also help in collating all possible suggestions related to development of drugs and vaccines and other therapies related to COVID-19. And this way, we will be really able to help our scientists a lot in their efforts in developing vaccines, drugs, and other therapies for COVID-19. So I look forward to your contribution, and I hope together we will all win in the COVID-19 war. Thank you. Jai Hind.